Welcome back. So I think we ought to do a little stoichiometry with predicting chemical reaction products in the middle of all of it. This would be the last thing we do in this unit before we take a test. So I believe what I'll do on this problem, or just work out a problem and do this deal with the whole geschmutz. Do it as a limiting reactant, percent yield, the whole thing. So let's see. So let's say that what is the percent yield when 3.41 grams of magnesium reacts with 7.21 grams of nitrogen. Wow, I don't have any idea, so I'm going to make something up. I'm going to make up something that's smaller than those because I have no idea what this should be. 2.45 grams of product is produced. So there we go. And it doesn't say much of anything about this problem other than there's two things that react together and they make some product, and the amounts are given of these two reactants. So no matter what else happens in this deal, we have got to come up with a balanced chemical equation. We're going to get nowhere fast without a balanced chemical equation. So we've got magnesium reacting with nitrogen, and that's all we know. And so it would be handy if the instruction here provided a little more information about what kind of a reaction this is. So what I'm going to say is this is two elements. We've got element 1 and element 2, although nitrogen is molecular. But element 1 plus element 2, odds are really long that is a synthesis reaction. So I'm going to combine magnesium and nitrogen and make magnesium nitride, Mg3N2. If you're wondering how that works, Mg plus 2, nitrogen negative 3. To get the charges to balance, I've got to have 3 positive 2 charges to deal with 2 negative 3 charges, so that's positive 6, negative 6. All that old stuff is still in the game. So let's see, to balance this, on this side I've got 2 nitrogens, this side I've got 2 nitrogens, this side I've got 1 mag, this side I've got 3 mags. There we go. Okay, so now I've got 2 amounts of reactants, so this is a limiting reactant problem for sure. So I've got 3.41 grams of mag, and I need to know how much product can be made from 3.41 grams of magnesium, so away we go. So I'm going to go from grams of magnesium to moles of magnesium, and from moles of magnesium to moles of magnesium nitride, and from moles of magnesium Mg3, holy crap, Mg3N2. That's not a whole lot better, is it? Mg3 N2, 2 grams of magnesium nitride. And there you go. And it says here in fine print that 1 mole of magnesium has a mass of 24.31 grams. And let's see, it says right here that 3 moles of magnesium produce 1 mole of product, and 1 mole of product, which is magnesium nitride, has a molar mass of 100.9, I did this a second ago, 0.95 grams. And everything divided out except grams of magnesium nitride. There we go. That 5 goes right there. And that still divides out. So, here we go. Do. So we've got 3.41 times 100.95 divided by 24.31. 24.31 divided by 3. And that would be 4.72 grams. 4.72 grams of magnesium nitride. Okay. So let's do this one in red, I guess. Why not? So now we've got 7.21 grams of nitrogen. And so I'm going to see how many grams of product can be produced from 7.21 grams of nitrogen. So I'm going to go from grams of nitrogen to moles of nitrogen, and from moles of nitrogen to moles of magnesium nitride, and from moles of magnesium nitride to grams of magnesium nitride. And everybody divides out except the grams of magnesium nitride. So 1 mole of nitrogen has a mass of 28.02 grams, and 1 mole of nitrogen produces 1 mole of magnesium nitride, 1 to 1, and 1 mole of magnesium nitride again has a mass of 100.95 grams. So let's do that one. Oh, this one's going to be quite a bit more than that one, it looks like. 7.21 grams times 100.95 divided by 28.02. Bong. 26.0 grams per near to the correct number of sig figs. 26.0 grams of magnesium nitride. Okay, so I'm going to go with magnesium is limiting, so that's the 4.72 grams of product is the maximum that can be made, or in other words, that would be the theoretical yield right there. And so then I'm going to, let's see, it said we produce 2.45 grams of product, so there is 2.45 grams of magnesium nitride actually produced. That would be the actual yield right there, the part that was actually produced, and the theoretical yield was 4.72 grams of magnesium nitride. And for those of you who uh, are taking counsel from the old man and paying attention to the units, this deal right here, when you do a percent yield calculation, it has to be the same stuff in the numerator and the denominator. It won't work any other way. So when you do these, and I'm wondering, I better not be going grams of and putting an X right there, because it won't work. It has to be, when you do a percent yield calculation, it's got to be the mass of the same stuff. So we're seconds from a clean getaway here. That would be 2.45 divided by 4.72 times 151.9. To 3 sig figs, I've got 3 sig figs. I had 3 sig figs right there, so I get 3 sig figs right here. I had 3 right there, so I get 3 right here, because the 3 is the smallest number of sig figs in that whole calc, and 3 is the smallest number of sig figs in that whole mess. And that was given to 3 sig figs. The actual yield was given to 3 sig figs. So I got 3 sig figs divided by 3 sig figs, so this percent is 3 sig figs, so this percent yield would be 51.9% yield in magnesium nitride. And there you go. Stoichiometry with predicting chemical reactions. The name of the game, pretty much, is get a balanced chemical equation. And that's going to be a little tough if you don't have a reasonable grasp on what the types of chemical reactions are and how each of them work, and then be able to identify which one you've got when you read the question. This particular question was a little thin on information. It would have been handy to say undergoes a synthesis reaction, but it didn't. Then once you get the balanced chemical equation, then it's stoichiometry on out. And there you go. Take care then. Bye-bye now.